I'm Sylvain Lotto, Product Manager for the Reality Modeling Academy, and yeah, I will be your presenter today. So first, let's talk about reality modeling, what it is. Reality modeling is the process of capturing existing conditions in 3D using one or a combination of devices. It can be UAVs, handheld camera, laser scanner, smartphones, and this to support applications such as mapping, design, construction, inspection, and asset management. For mapping, reality modeling can be applied to planning application in urban or municipal environments. Bentley reality modeling tools allows to create 3D models of large areas containing billions of triangles and still work with it seamlessly. In design, reality meshes can be used to better understand existing conditions, to help manage the risk of constructability issues and identify potential issues earlier. So it allows saving time with primarily design, risk management, and understanding the existing conditions. In construction, the continuous survey capability provided by UAVs and other reality modeling techniques really allows to more easily manage changes on construction sites and also create up-to-date documentation. So it allows progress management and change detection, verification and visual condition assessment, as well as construction documentation. The 3D reality mesh can be used for visual operation, allowing users to easily document existing conditions and link the model to their information management system. Users can easily navigate the reality mesh virtually and also query the database to quickly and visually find specific equipment to maintain, replace, or inspect. This can be used for training and simulation, operating condition on assets, and asset management in general. During inspection, the reality modeling can speed up the process and offer higher quality, more repeatable documentation of the inspection. Reality modeling allows easier access to hard-to-inspect locations. So here is a video demonstrating how easy 3D mesh can be produced using ContextCapture. ContextCapture is the core engine to generate 3D meshes from photos. So with a set of photos taken from a drone or a handheld camera, following some specific rules of overlap, etc., you can then just easily drag and drop your photos in the software, and within a few clicks you will be able to generate a 3D mesh. The first step of the process consists in submitting the error triangulation. The error triangulation is the step that will align the photos together, finding their relative poses. And you will get here first results, interesting results, which give you the photo position in space. This can already be used for inspection. Then you run the 3D mesh reconstruction and you get your 3D mesh model. This model can then be used in many Bentley applications, and you can seamlessly work with it, doing analysis on it, volume calculation, and so on. We'll see more of this later. Now let's have a look at hybrid modeling. What we call hybrid modeling is the use of a combination of photos and LiDAR. LiDAR meaning laser scanning system. To use them both to generate 3D models. Historically, photogrammetry and laser scanning has been described as competitors, but at Bentley we know that both techniques have their pros and cons, so why not leveraging both at the same time? First, let's have a look at what are the requirements for a successful 3D model. What are the challenges, main challenges? So first, high and inaccessible areas are a main challenge for both laser scanning and photogrammetry. This can be solved by using drone, and of course from the ground this is something that cannot be achieved. We want certified accuracy and repeatability. This will be provided by laser scanning. But we also want high quality color information provided by photogrammetry. Then, if we want millimeter resolution, we cannot achieve this from a drone. We have to get closer to the subject, so we need ground acquisition. This can be done both by laser scanning and photogrammetry. Finally, we want to capture also very thin parts for some specific subjects that can be tricky to get with photogrammetry. And of course, from drone, since you have a lower resolution either on your laser scanning or your photos. So here laser scanning will be good to have. Finally, on glossy and uniform materials, photogrammetry can struggle a little bit. So here again, laser scanning will have the edge off. And finally, occlusions, which you get a lot with laser scanning and less with photogrammetry, since you are constantly changing point of view during your photo capture. So all in all, here we have a table of both strengths and weaknesses of technique and acquisition type. And we see that if we want certified accuracy, repeatability, something working on uniform and glossy materials, high quality color information, this on both high and inaccessible areas and with a good resolution, we would need a combination of everything. So to get the best reality mesh possible in challenging conditions, you will need a combination of techniques, laser scanning and photogrammetry, and with different means from the ground and using drones. So thankfully, ContextCapture is able to generate this kind of 3D mesh using combination of laser scanning and digital photograph, should it be taken from the ground or from the drone. It can take anything as an input to generate a 3D mesh. I will showcase this chemical plant use case that we have done in partnership with Topcon. The acquisition was done with multiple devices. First, we have used a drone, which was Topcon Falcon 8, with a Sony ELCE7R, which is a full-frame camera. And 131 photos have been taken from the sky for about 30 minutes. From the ground, we used a Nikon D810, which is also a full-frame. And we took from the ground more than 1,500 photos. And it took about 1 hour and a half. Also from the ground, we used a laser scanner, Topcon GLS 2000, and we captured 56 million points in more than 2 hours. Here is a short video of the results that we got. So we can see that scene members have been perfectly captured. We have great details on the small parts and a great photorealistic model on which we can read labels and so on. So we get highly detailed 3D mesh that can be used further. Now I will talk a little bit about the latest innovations in reality modeling. Bentley is really proud to announce a range of innovation in reality modeling that will contribute to BIM workflows. So, as I mentioned, Bentley ContextCapture is a core engine allowing to create the digital twin and has historically been running on local computers on premises. And we have been integrating the reality mesh into our existing application for viewing purpose. The key advantage of reality modeling over the competition is definitely in the interoperability with vertical applications that Bentley offers, avoiding inevitable losses of information and limitations between heterogeneous products. To accelerate the adoption of reality modeling solutions in various industries, we are releasing new applications, increasing the flexibility of the solution. First, we have a new mobile application to capture photos on the go with a smartphone, a new service to process field data using the latest cloud technology, and project-wise ContextShare to store, share, and index your reality data. So, what are the benefits of using reality modeling for construction? It allows all stakeholders to have a global and accurate perspective of the job site. It allows project managers to monitor and evaluate progress and performance of a given job versus a design. The calculation of cut and fill quantities as often as necessary. Improve safety by, for example, not having to climb on a stockpile to do a survey. And so, of course, lower cost of inspection survey and as-built survey, since you don't necessarily have to send a team on the field for the survey. Here is an example of a 3D mesh of a construction site at a specific moment. It can be used to review the condition of the construction site and have a look at the works going on. Reality modeling can be used to monitoring new construction, enabling them to take into account the timeline, turning successive 3D model properly georeferenced together into a 4D experience. Beyond the case illustrated in this video, we think that making reality modeling a more ubiquitous process will help collaborative work between the field and the back office, improve fixing and expansion processes as well as documentation of issues. This 3D reality mesh was created using ContextCapture, and images were acquired with a drone using an orbital flight path at about 50 feet, and the team captured about 200 images weekly. So the acquisition time was really short, about 10 to 15 minutes, and the model uses the geocoordinated of the drone to get the georeferencing. So it's a really simple project that is conducted over time, several times, and only a few minutes to capture and to process. Okay, this video is an example of a large-scale road and bridge construction site in the eastern United States. The team created a 3D engineering-ready reality mesh to monitor and quantify the construction progress compared to the actual design. Here we can see the model in ContextCapture, and now in the viewer, the resulting mesh. And this mesh has been imported in OpenRoad Designer to compare with the actual design. They discovered that some areas of the projects were radically different between the design and the actual construction. Here we can see the comparison of the two. Finally, here we can see the model exported in Cesium Web Viewer to easily share your 3D meshes with your the different stakeholders. In construction, you might not be able to fly drone everywhere. Of course, there are some restrictions. If you are over a densely populated urban area, in an airport zone where you are not allowed to fly, and if you don't get the right certification and permits requirements. That can be sometimes tricky to get. So we can imagine other solutions, like mounting a simple camera on a crane hook. You can capture condition of a full construction period. It's simple and easy to implement, and it's just quite straightforward approval and adoption scheme. This is a test that has been done on a construction site with such a camera mounted on a crane hook. And you will see that the results that we can get from this quite simple workflow are pretty good. You can imagine repeating this survey every week to monitor the changes of your construction site. Here is the 3D model generated from this data capture. In this case, it's a simple GoPro mounted on the crane hook. So I've talked about the new cloud service, and let's see how it is ideal for the construction industry. It instantly processes 3D model of as-is situation, quickly and securely share and manage 3D model from anywhere across project team for office field and collaboration. Remember, I talked about project-wise context share. So when processed through the cloud, your reality meshes will be stored on the context share and can be automatically shared with your collaborators. You don't need any high-end hardware requirements nor IT constraints, since everything is processed on the cloud. It's a pay-per-use model, and it's a centralized solution for multiple cloud services from hardware providers. So ContextCapture Cloud Processing Service enables you to upload photos and quickly generate 3D engineering-ready reality meshes, orthophotos, and digital surface models. Access using the ContextCapture mobile app or the desktop application from a web-based console. And so you can easily view and share your reality meshes. And project-wise context share is a connected data environment, and it allows you to quickly and securely manage, search, download, and stream reality meshes and their input sources. So to end this presentation, I will talk about Miron Infrastructure conference that we are holding this year in Singapore, and especially the Be Inspired Award. This year we have a total of 48 reality modeling projects that have been nominated, and 30 other more that are using ContextCapture in other categories. So we are seeing a really wide adoption of reality modeling in general at Bentley, and we found this is really great. I invite you to get a copy of Bentley yearbook as soon as it will be released, since you will have a lot of examples from the different nominees and awardees. And this is a great showcase for the reality modeling product and workflows. I will end with the Reality Modeling Academy, which I am the product manager. This is a new initiative at Bentley with the following objectives. We want to increase awareness and adoption of reality modeling in general, offer best practices for reality modeling data capture and outputs, ensure easy integration of reality modeling solutions in your workflows, share innovative uses of reality modeling in industrial workflows, and bring an exhaustive reality modeling knowledge base. So if you want to know more about the Reality Modeling Academy, please feel free to contact me. So that's end my presentation today, and I will be happy to answer your questions. And thanks for your attention. Thanks.
Great. Thank you, Sylvain. And at this time, I'll hand it back over to Sylvain and Stephen for Q&A.
Great. Yes, we have some questions. First one is, can this be used for inside space, such as inside a plant?
Okay, so the answer is yes. You can use photogrammetry inside plant as well, and you can use, as we saw, a combination of laser scanning and photogrammetry. The tricky thing in inside and confined spaces is a lack of distance from the subject. So to achieve good results in interior space, you will need camera with larger and wider field of view, so short focal lenses. And you will need to have a specific acquisition pattern to ensure enough overlap between the consecutive photos and so on. But in confined spaces and interiors, we would recommend the use of both laser scanning and photogrammetry.
The next question is, would there be any issues in using airborne LiDAR in these workflows?
It's possible to use airborne LiDAR. It depends on how you want to combine these with photos, or if you want to use only airborne LiDAR. ContextCapture can input any type of point clouds, should it come from static laser scanners or mobile mapping system mounted on either a plane or cars. The only thing is we need both the point cloud and the trajectory file to be able to process them in ContextCapture.
The next question. What kind of accuracy can we expect from reality meshes generated from photos?
Okay, so from photos, you have to have the notion of the two precision factors. First will be the global georeferencing that it can be achieved using control points. So if you have precise control points, let's say if you have 1 to 2 centimeter precision on your control points, you can expect a maximum accuracy of your spatial position of 1 or 2 or a few centimeters. But then you have the relative accuracy of your 3D mesh. And this will be dependent of your photo resolution. If you have, generally we say that the relative accuracy of your 3D mesh will be 2 times your pixel size, projected pixel size on the scene. So if your photo has a resolution of 1 centimeter per pixel, you will get an approximate precision of your 3D model of 2 centimeters, plus or minus 2 centimeters.
Next question. Can reality capture be used for other tasks other than visualization of construction site and monitoring progress?
Yes, it can be used for a typical example would be capturing an area. So you will get a 3D mesh of a green field. Then in other Bentley application, from this 3D mesh you can automatically extract the ground and use this terrain model as a layer for your underlying layer for your design.
Thank you. Next question. Can ground control points be added to the mix in order to get a model that is 100% to scale?
Yes. So ContextCapture features ground control point editor in which you can import your ground control point coordinates and do measurements in the photos. So this will ensure you really good georeferencing and perfect scaling of your 3D mesh. We also have new innovative way to do so. We have in the latest version of ContextCapture introduced the automatic detection of QR codes. The QR codes can contain either coordinates or scaling information. So basically you can print out two QR codes with the information of distant constraints, for example, put them in your scene before doing the capture, and ContextCapture will automatically detect the QR codes and automatically scale your 3D mesh. And this works as well for the georeferencing with control points. So this prevents to have to do the manual measurements of control points or of constraints in your photos, which can be quite tedious work.
Thank you. There was a follow-on to that question. It says, can ContextCapture create orthomosaics?
ContextCapture can generate orthophotos, so the projection of the texture on the horizontal plane. If you use ContextCapture editor, you will be able to create orthophotos from other point of view or orthophotos of facades, etc. But it's not per se an orthomosaic, since the orthophotos we produced are actually the texture of the reality mesh that is projected on the vertical or horizontal plane.
Great. Okay, I think we have time for one more question. Can I use drone with RTK positioning system?
Yes, of course. So you can use drone with or without GPS information first, and then if you have RTK information, this will give you precise information on the photo position, and we can leverage this precise position information to get rid of the needs of control points. So yes, we can definitely use RTK within ContextCapture and have the arrow triangulation solution to best fit the photo position that has been input.
Great. Thank you. So with that, I'm going to turn this over to Natalie.
Great, thank you, Steve. And big thank you to Sylvain for a wonderful presentation, and a big thank you to all of you for your questions and participation. Thanks again, everyone.